conjecture we're going to look at is the parallelogram opposite angles conjecture. Now, if you notice what says the opposite angles of a parallelogram, what did we decide the opposite angles of a parallelogram are? Congruent. Okay? What did we decide that the consecutive angles of a parallelogram are?
180.
They add up to 180, so what's a fancy name for that?
Supplementary.
Supplementary. Okay? The opposite sides of a parallelogram are congruent. And the diagonals of a parallelogram do what?
Bisect each other.
Bisect each other. Okay, so I'll let you get those down and then we'll move on. Okay, so let's go ahead and look at an example on this next slide. So we need to find what M and what N equal. So first of all, what does M equal? 28 centimeters, because those are opposite sides, and we know that the opposite sides of a parallelogram are congruent. What about N? 13, because those are diagonals, and diagonals are bisected in a parallelogram. Okay, let's look at the next diagram. I need to find R and R, S, and T. Okay. Do I know any of those? T is 112 because those are opposite angles. Opposite angles are the same measure. So how do I find what S is? They're supplementary, so I'm going to take, to find S, I'm going to take 180 minus 112, and I get 68 degrees. Questions? Okay, we're going to look at this next one here. It says, what is the perimeter? Now, perimeter means what? Refresh my memory.
Distance around.
The distance around. So what I need to do in order to find the perimeter is I need to find what X equals. How can I find what X equals?
X minus 3 equals 17.
I know that these two have to be the same measure, right? So I've got X minus 3 equals 17. So what does X equal? 20. So really, if I put in 20 for X up there, that gives me the length of that side. What is the length of that side? 23. So I've got 23 on the top, 23 on the bottom. Okay. What do I have on the left and the right? 17 and 17. So if I add all those up together, what do I get? 80. Oops, that was a bad 8. We'll try that one again. Now, for those of you wondering, how did they get 80? 23 and 17 makes 40. So if you have 40 and 40, that gives you 80. Okay. Questions? Okay, the last thing we're going to talk about is something known as vectors. And a vector is a quantity that has both magnitude and direction. This is something that's discussed a lot in physics. But a vector is a quantity that has both magnitude and direction. Now when it says magnitude, that means size. Okay? So, vectors describe quantities such as velocity, acceleration, and force. And we represent a vector by an arrow. And this is all taken from your book on page 282.
Oh, yeah.
Okay, so on page 282. So real quick here, we see that we've got an engine velocity of 560 miles per hour. The engine is actually moving in this direction. Okay, notice you also have a wind velocity at 80 miles per hour. So what that wind actually does is that wind pushes that plane a little bit off course. So when planes are flying into wind, they actually need to account for that. And they need to change their heading and their course based on the wind. Okay. So a resultant vector is called the vector sum, and that's what actually happens when you have a wind. Okay, in that plane in that example before. And basically, how do you draw the resultant vector? Well, you make a parallelogram with the vectors as the sides. Okay, you make a parallelogram with the vectors as sides. The resultant vector is the diagonal of the parallelogram from the two vectors' tails to the opposite vertex. Okay, so if you notice my two directions, I started with the velocity right here. Here's the velocity vector. Okay, that's in purple. What ends up happening is here comes the wind. The wind is going to push you this direction. So what I'm going to do now is I'm going to make a parallelogram. And how I'm going to make a parallelogram is I'm going to translate the blue vector up there to the top. And I'm going to translate the purple vector right here to the right. Now what ends up happening is the resultant vector, or the actual course that plane takes, is here in the middle. And planes actually do have to account for this. Another thing that would have to account for this is a ship. Okay, when you have a current and you have the waves. Okay, have you ever been on the lake and then you've actually got a current and it doesn't push you straight, it actually pushes you at an angle? Okay, generally it's going to be along the same thought. Okay, so that's a little bit about vectors. Vectors are used in a lot of places. And I think you'll see a few examples on your homework. So what I need you to do is on page 283 through 284. Okay. What I need you to do is 1 through 13. You don't have to do 7 or 8. Okay, 1 through 13, not 7 or 8.